Let's look into one of the main AutoScholar functions. In progression mapping, we identify the various routes to graduation taken by students of an academic program. We define a route as the set of course combinations chosen by students in each semester. An application of progression mapping is to identify gatekeeper courses, or killer courses, which limit the graduation rate. A gatekeeper course serves as a prerequisite to many other courses, and has a high failure rate. A high fail rate on, for example, an elective course, does not necessarily limit graduation. However, a high fail rate on a foundation course can severely limit overall student progression. Let's look at a progression map. We see here a program with 100 students entering the first semester of study. After one semester, 70 students have passed everything, and about 30 students haven't. So each edge is one semester, and behind each vertex is a combination of courses that have been passed. At the end of each semester we have a set of course combinations that have been passed, which gives us a certain number of credits passed. So we generate a graph, and overlay this graph on the axes with number of students in a vertex on the y-axis and number of credits passed on the x. The graph generated then shows us all the routes taken by students to graduation. We can look for particular features on this graph. For example, we can identify vertices that have a high frequency of students going on to extra time to graduate. By identifying which course or course combination causes this branching, we identify the killer course combinations. In some cases, by simple re-timetabling, we can facilitate some over-crediting and so achieve higher graduation rates. So this picture is useful for us to understand the difference between the curriculum that we've designed and the curriculum from the perspective of the students. We might not be aware that so many routes exist, we might not be aware that there are specific fail-out points that exist where we can apply support. Of course, this is clear to see for so-called structured programs. The same is true even when there is less structure. Even if we have a program with an intended large number of free choices, still, there exists a limited set of choices which students tend to take. For example, a BA program may have many possible choices, but there may be just 7 or 8 main routes that students take. When we understand these routes, we are able to direct resources to places that will make the best difference to support a better graduation rate. Curriculum identification is another application of progression mapping. We can select the route to graduation by the majority of students, or the route which has the shortest time to graduate. By looking up the courses behind these vertices, we determine the best route to grad, which we hope matches our curriculum design. Here's a picture of a real example where this was done. Highlighted in white is where the system has correctly found the placement of the courses. Highlighted in yellow is where it got it wrong. It thinks Thermodynamics 1 is a third-year course, when it belongs in the second year, and it thinks Thermos 2 is in the fourth year, when it belongs in third. It also got these other courses wrong. Now, if we analyze this, we see that because the fail rate on Thermodynamics 1 is so high, students are only passing it in third, which is why the system thinks it belongs there. Furthermore, because this course is a prerequisite to Thermos 2 is only passed in fourth year. Then since these other two courses are prerequisited by Thermos 2, they also appear in the fifth year, which doesn't exist according to our curriculum design, but which certainly does in the minds of students. So these 4 errors are really one error, which shows us the key gatekeeper of this entire academic program. Overall then, progression mapping helps us identify and even quantify the difference between our curriculum design and the curriculum from the perspective of the student.